So with all of that in mind, let's try another one. So the general strategy, we need to find the vertex and then use symmetry. We'll pick one point next to the vertex, find its coordinate point, and then use symmetry to find a third point on the other side of the vertex. So this function we have f of x is 2x squared minus 5. And I'm just going to rewrite the vertex form so that you become more familiar with it. But notice this one doesn't have this big expression squared. So this one's a little bit tricky just because it's actually simpler than these problems. So it might throw you off. But one way you can think about this is as f of x is 2 times x minus 0 squared minus 5. And that way it might be a little bit more obvious that the x coordinate of our vertex is 0. Or we're not shifting this function left or right. We're just shifting it down 5. And it's also getting scaled by a factor of 2. But we're just concerned with the shifting in order to find the vertex. So in this case, remember the vertex is the x value you plug in here to make this 0. So in this case, that's just 0. So 0 for x. And when you do plug in 0, this whole term goes away, and you just get minus 5. But when you subtract 5 on the outside, you're just shifting all your function values down by 5 when, again, we're comparing it to this parent function. That's a little sloppy, but it's supposed to go through the origin. So that parent function gets shifted down 5, and then, like I said, this 2 in the front would make it skinnier. It scales it by a factor of 2, or it doubles all the y values. So we know this vertex. We can plot it at 0 for x and minus 5 for y. So 2, 3, 4, here's negative 5. And now this y-axis, this is our axis of symmetry. So our function will be a mirror image on either side of it. And we know the a value here is positive, and since a is positive, it's going to be opening upward. So let's pick one point on either side of our vertex, and I'll just pick the point of 1. So x equals 1, and we're going to plug that into our function to see what y would equal. So f of 1 is 2 times 1 squared, which is just 1, minus 5. And 2 times 1 is 2, so you get 2 minus 5, which is negative 3. So I can plot that at 1, negative 3. And it's symmetric on both sides of the y-axis. So if I graph the point negative 1, if I plug negative 1 here, again, when you square it, it just becomes positive 1, and you end up with this exact same equation. So y, or your function value, would again be at negative 3. And like I said, you can figure out when it crosses this x-axis. We can set our function equal to 0 and solve. So add 5 to each side. We're essentially just solving for the square root because we don't have that middle x term. So adding 5 over there, and then dividing everything by 2, you get 5 halves, and then you have to square root everything. So x is plus or minus the square root of 5 halves. You need the plus or minus to account for the fact that there are two solutions, one of them positive, and then one of them negative, that when you square it becomes positive. So these are going to be irrational numbers. It's not going to be very easy to plot that. In fact, you probably just need a calculator to figure out what that even is equal to. So we're just going to freehand this, and it's going to look something like this. But again, if you want to be more precise, you can calculate this numerical decimal value and then plug that in, since we just set y equal to 0. And that is where the x-axis is. The x-axis, or the x-intercepts, is when y is equal to 0. So this just gives you more information, but with the Khan Academy Interactive Grapher, it will plot itself if you just give it, I think, 3 points. So you don't have to worry too much about this. It'll just automatically go right through exactly the points that it should. So let's do a couple more of these just to get the hang of it. And I'll rewrite it. Y is minus 2 times x minus 1 squared minus 4. So our vertex, we're seeing how much we shifted the x values, and a positive 1 would make this 0. So that is the x value of the vertex. And our y value is whatever we add or subtract on the outside. Because remember, if you plug in 1 here, you just get 0 times negative 2, which is 0. So this would all go away, and you just get negative 4. So we can plot this vertex at 1, -4, right there. So our axis of symmetry will be through the x value of 1. It's going to be a mirror image on either side. It's got a negative coefficient, so a this time is negative, which means it's going to open downwards. So we don't even need to worry about x-intercepts or finding those because it won't go through that. Now we can choose either 0 or 2 here. Just pick a point on either side or pick one point on either side, and then we can use symmetry to find that third point. So I'm going to choose an x value of 0 just because that's easy to plug in. So let me change colors, when x is 0, y would be -2 times 0 minus 1, which is -1 squared, -4. And we have -1 squared is +1. So you have -2 times +1, which is -2, and then -4. So you get -6 here. So when x is 0, y is -6. So that's the point 0, -6, which we can graph right here. We'll use symmetry now. Actually, let me change back to green for that. So the other point, the third point on our graph, is just going to be 1 to the right, but with that same y value of -6. So it's going to be right there, and we can connect these now. And that's at least a rough sketch of what the graph looks like. But again, we have this symmetry because if you plug in 2 here, you get 2 minus 1, which is 1 squared. And so instead of -1, you would get +1. But regardless, when you square 1 or -1, you still get back 1. So you end up with this same equation here and get -6 for your y value. All right, let's do one last problem. So let me just scroll down to that. And we've got a fraction, so maybe a little bit harder, but it's still the exact same strategy. So I'll rewrite it. G of x is -1/5 x plus 5 squared minus 2. So our vertex is the x value that makes this 0. So that'd be -5. And then when you plug in -5, this whole thing would go away because you'd have 0 times something, which is always 0. And you'd just be left with -2. So that's our vertex. We can plot that. And since our a value is negative, we can expect this one to open up downwards. So -5 for x, that would be right here, and then -2 for y, so right there. So it's going to be opening down. This is our axis of symmetry at x equals -5. So we want to pick a point either 1 over on the left or the right. But like I mentioned for the first problem, if you want to pick something 2, 3, 4, 5 points over, that's fine. You just have to go the same distance to the other side. So if you go 5 to the right, then you have to use 5 to the left, since those points would both have the same y value. So we're going to pick, let's say, -4 here. So I'll plug in x is -4 into g of x. So g of x, or g of -4, would be -1/5. And then we have -4 plus 5, which is 1 squared minus 2. And we're going to end up with a fraction here. So we could also take a different approach. But 1 squared is 1, so you have -1/5 minus 2. And you could use a common denominator here, but effectively you're going to get -2 1/5. So that's our y value, so it goes through at -4 minus 2 1/5 is -2.2. So you could use this, but maybe your graph isn't that precise. Maybe you want to get rid of that fraction. So if we look at this again, we want to think if this squared expression, when we put in an x value, if it becomes some multiple of 5, then we can cancel this out. So in fact, if you plug in x equals 0, this would just be 5 squared, which is 25, and 25 divided by 5 is 5. So you can just get rid of the fraction there. So that might be a better approach. Let me just make some room. We'll try it that way. But this way would work. You had a point, and then you can use symmetry to find that other point. But sometimes it makes sense to look at values of x that are further away from this line of symmetry. So we're going to do x is 0. So that's all the way over here, which means we're going to have to go 5 units to the left over here. I'll even need to put in some more dash marks, so maybe something like right over here for that one. So let's put in 0 here. You get g of 0, which is minus a fifth times 5 squared, which is 25. So minus 1/5 times 25 minus 2. Now 25 divided by 5 is 5. So you get minus 5 for this, minus 2, which is negative 7. So it goes through at 0, minus 7. And let me go back to that yellow. So minus 7, so 2, 3, 4, 5, 6, 7. So right here. And we'll do the same thing when x is negative 10. So if you plug that into here, you would get minus 5 squared. But minus 5 squared is still 25. So you'd end up with the exact same equation, which is why we have this symmetry. So at negative 10, it's also down at this negative 7 for y. And from here, we just connect them. And in general, well, we knew it was negative, so it opened downward, but it was a fraction that we're multiplying. And if it's a value in front that is less than 1, so it's some type of smaller fraction, then it generally opens up in this very wide fashion. Now, if this is a value much bigger than 1, like let's say 3 or 10 or 100, then that actually makes it much skinnier. So if it's less than 1, it makes it wider. If it's greater than 1, for this coefficient out front, it makes it skinnier.